If you're watching this video, you either missed a lesson on absolute value word problems, or you're looking for a refresher while you're doing the homework. So this is really kind of a continuation of the lesson before. So if you haven't watched the video on absolute value equations, or you weren't there for class, you really want to make sure you watch that video because you're going to have no idea what's going on here. That said, up at this point, I'm assuming you experienced absolute value equations. Now this next slide here is pretty much what we talked about last class, which is that to solve an absolute value, to solve an absolute value equation, you got to get the absolute value completely by itself. And then we're going to set up two equations, one where it's the positive version and one where it's the negative version. And then it's going to be business like usual. We're going to use the inverse, the opposite operation to solve for the variable. Now, when I talk about absolute value equation word problems, I'm going to switch to the other tab now. Here's the thing. Yes, there's going to be a word problem, and yes, I'm going to tell you where everything comes from. But in this class and on the test, you're going to get the problem, always. So if you're really worried about time, just go for the word problem. I mean, just go for the actual equation. But let's talk about what this is. So this paragraph here says the average number of seeds in a package of cucumber seeds is 25. So average numbers is something that is important. It's usually about 25. The number of the seeds in the package can vary by 3. So that means there could be 3 more than 25. There could be 3 less than 25. They want to know what the maximum and minimum number of seeds can be in the package. So the reason why this is here, and I don't think any of you guys have taken any science classes yet, but I'll tell you that in science, there's this thing that's talking about experimental versus expected, and that equals kind of like the error percentage type thing. It's a little fancy, but just hear me out. This is what the actual number in the package is. This is what they expect it to be. And this is the possible difference it's supposed to be. So they say that always it's going to vary by 3 when we're looking for the maximum and the minimum. It's not going to have any more than 3 from 25. It's not going to have any less. So what that means, all that really means, is we're going to solve like we always have. We don't have to solve for the equation this time, but we are going to set up, make step 2, a positive version. And this positive version is going to be the maximum. That means that this is the most number of seeds that can be in the package. And then we're going to set up a negative. This is the smallest amount of seeds, because this means it's going to be 3 less than, and this means it's going to be 3 more than. And then from here, we're just going to solve. So I'm going to add 25 over, and I'm going to get x equals 28. I'm going to add 25 over, and I'm going to get x equals 22. And you can really clearly see here that, like, this is going to be the maximum because 28 is bigger, and this is going to be the minimum because 22 is smaller. Let's take a look at a couple more problems. This one here, same thing. The mean distance of the Earth from the Sun is 93 million miles. That means it's about 93 is our like a controlled number. The distance varies by 1.6 million miles, meaning it's either going to be 1.6 more or 1.6 less. That's where this equation comes from. So I'm going to switch pens for a second because I'm going to need to try something. So now in our step 2 here, we're going to have x minus 93 is 1.6. This is our positive version. Now we're going to have our negative version. X minus 93 equals negative 1.6. Right? So again, we have our little third step here. I'm going to add 93 over. I'm going to get x is 94.6. And I'm going to add 93 over. And I'm going to get x is, if we put that in the calculator, I want to say that's 91.4. And again, this one's the bigger one, so it's our maximum. This one is our smaller one, so it's our minimum. And that's really all there is to it. You read the word problem, it tells you what it means, and you solve just like you did before. For the purpose of this class, I'm not making you make the equations. Look at another one. Members of the track team can run 400 meters in an average time of 58.2 seconds. The fastest and slowest times varied by the average by 6.4. So the fastest is going to be 6.4 less. And actually, and the slowest is going to be 6.4 more. So they're asking what are the maximum and minimum times. And we're still going to follow our same rule, even though fastest and slowest kind of makes it seem kind of wonky, but it's still going to be the same thing. We're still going to make a positive equation for our equation here. And we're still going to make a negative version. So I'm going to add this to both sides. I sure like this new pen. Definitely got its uses. And if I'm correct, this is 64.2 seconds. And this one, I forgot to make this negative. Let's try negative. If I add 58.2 to both sides, I'm going to get, no lie guys, I'll pull my calculator out. I don't trust myself to do that number. There's a lot going on. I'm going to go to my handy dandy calculator. I'm going to do negative 6.4 and I'm going to add 58.2. And I get 51.8 seconds. So this is the maximum time and the minimum time. All right, one more. A machine is used to fill each of the several bags with 16 ounces of sugar. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, the bag is rejected. What are the heaviest and lightest bags the machine will approve? So this is basically saying that no matter what, it can't be more than 0.3 more than 16 or 0.3 less than 16 because the machine is going to be like, nope. So it's going to be the same process. I'm going to have a positive version. And I'm going to have a negative version. And same thing, I'm going to solve. And I'm going to solve. And our bigger number is going to be our maximum. And our smaller number is going to be our minimum. So with the absolute value, with the word problem equations, this is all there really is to it. The paragraph explains to you what the equation does. And then you're just going to solve the equation like you have. But you need to remember, the bigger number is always going to be your maximum. And your smaller number is always going to be your minimum. If you have any questions on that, if you're really struggling with the absolute value part, go back to the absolute value equations video, send me a message on Remind, send me an email, whatever you need to do, but I'm here to help. That's all I've got for you.